Hello, here we are with the aggregate expenditure model, PowerPoint number 15. And I'm going to do a voiceover of this for the people that are absent. Sometimes it's easier to do a video. You can pause it where you want, and I can just get through it all at once, and there's no pausing in class for, taking notes and people to write down things. But you can ask questions in class, but if you do it ahead of time, it would be great. The aggregate expenditures model, which is this topic that we're on in our new Unit 4, refers to the economy's total spending. Aggregate just means total. Expenditures is spending. The aggregate expenditure model was developed by John Maynard Keynes. You're going to get to know him pretty well this semester. The basic premise of the aggregate expenditure model, also known as the consumption function graph, which I had you guys draw today. Actually, only second period drew it. But third period, you'll get to draw it tomorrow. It states that the amount of goods and services produced depend directly on the level of total spending. In other words, when total spending falls, total output, the GDP and employment decrease, and when total spending rises, total output, GDP and employment increase. It's very logical, makes total sense. You just have to get a hold of the terms and wrap your head around it. It's an illustration of the relationship between consumption and savings in the entire economy in the aggregate. Savings is defined as not spending, or that part of disposable income not consumed. So savings equals disposable income minus consumption. And here is the graph. Right now we're going to assume that the U.S. is a closed economy and that the only two variables are personal consumption and gross investment spending. We'll deal with government spending and net exports later. This is an example from 1988 to 2000. It's consumption and disposable income. The 45-degree line represents consumption equaling disposable income. And the curve represents total consumption. The vertical distance between actual consumption and the 45-degree line represents the amount saved. Here are all the years. The consumption schedule. There's a direct relationship between income and consumption. Our consumption line is upward sloping because when disposable income increases, then consumption increases. Makes sense. We spend more when we have more to spend. And this is a graph, kind of cartoon thing. I made a copy of it for you guys because I just liked it, and you do need to practice drawing the graph. It is in the chart of graphs. The consumption function measures different consumption and savings levels at different GDP levels. As GDP grows, everyone in the economy has more disposable income. Makes sense, right? Looking at this graph, we can see if disposable income for this economy is $5 billion, and consumption is $5 billion. Then consumers are spending all of their disposable income, so savings is 0. If the curve is plotted on the 45-degree line, the break-even point savings will be 0. However, as disposable income increases, consumption and saving will increase. The more we make, the more we spend and save. This causes the curve to fall below the 45-degree line, and the gap between the two lines represents the amount of our savings. But when we earn less, we spend and save less, so we see the consumption curve rise above the 45-degree line. At this point, the economy is dis-savings, or consuming more than its disposable income. You can calculate how much disposable income the economy consumes and how much it saves by using the formulas average propensity to consume and average propensity to save. APC equals the percentage of income that is consumed, and APS is the percentage of income that is saved. We're going to use Y for that. APC is consumption over income. APS is savings over income. APC equals consumption over income, and you can do the math here, and you can see that consumption would be 0.96, savings would be 0.04, it equals to 1. Here's another example to practice plugging this in so that you get a feel for it. A lot of it is very intuitive and simple, but you probably want to write down the formulas. Since there are only two things you can do with income, consume or save, APC plus APS always equals 1. And what if total output changes or increases? You can calculate the percentage of this new income that will be consumed and the percentage that will be saved by using the formulas marginal propensity to consume and marginal propensity to save. MPC equals the percentage change in income that is consumed, and MPS is the percentage change in income that is saved. That should be an equal sign, and there's a lot of typos here. Let's say that your household income increases $1,000. What percentage of this $1,000 will you consume and how much will you save? MPC equals the change in consumption over the change in income, and you can draw that with a little delta. And MPS is the change in savings over the change in income. Again, you can use the delta, and whenever you get numbers, they're going to be easy numbers. They're going to be 0.75, 0.25, 0.1, 0.9. As you can see, 75% of your new income you consumed and you saved 25%. Since there are only two things you do with your new income, MPC plus MPS always equals 1. You always either consume it or spend it. Dun, dun, dun.